in this part, we are going to talk about a powerful concept in C programming called recursion. So by the end of this lesson, you will understand what recursion is, how it works, and when to use it. So recursion simply means a function calling itself. In C, a recursion is when a function solves a problem by breaking it down into smaller versions of the same problem and calling itself until a base condition is met. Okay, so let us now take a look at the structure of a recursive function. Okay, so every recursive function must have two key parts. Okay, so the base case, and this stops at the recursion, otherwise it would run forever and cause a stack overflow. Okay, you know, a function calling itself, it might result into infinity loops. Okay, an infinity loop. Okay, which can lead to stack overflows. Okay, so another one is the recursive case. Okay, and this is where the function calls itself with a smaller or simpler version of the problem. Okay, so let me show you an example here. So here we talked about the base case and even the recursive base. Okay, the base case and the recursive base. The recursive case. Okay, the base case and the recursive case. Okay, and the base case stops the recursion. Okay, so here, as you can see here. So here, as you can see, we have our main function. Okay, here, right here, our main function, and this main function is calling the count function. Okay, and we are passing in 5. Okay, as you can see, we are passing it 5. Okay, so here we have our count function, and it is returning something like a void. Okay, which we don't know, so it is returning nothing. Okay, so here, as you can see, here we are taking one parameter, which is n, that we have provided here. So n is equals to 5 in this case. So here, as you can see here we talked about the base case. Okay, and this one stops. Okay, stops the recursion. Okay, so here, as you can see, we majorly use if statements. Okay, so here, as you can see, if we check if n equals to 0, and if it is equals to 0, then we return. Okay, we return out of that function. Okay, out of that function. Okay, so as you can see, we use this one. So otherwise, if n is not equals to 0, otherwise, what are we going to do? We are going to print out n. After printing out n, we are going to do what is called like lowering. Okay, okay, reducing the n. Okay, so we are reducing the n by 1, and then we pass the results. Okay, in count down. Okay, in count down, and we call it again. Okay, like that. Okay, so when remember in the first case, n was 5. Okay, n was 5. Okay, and we reduce it to by 1. Okay, and now n is 4. Okay, and then we pass 4 in the countdown function, and then we call it again. Okay, so the function is calling itself again, but when n is reduced by 1. Okay, so as you can see, so this process continues. Okay, until n is equals to 0. We are going to be lowering until n is equals to 0, and this one is called the recursive case. Okay, which is where the function calls itself with a smaller or simpler version of the problem. Okay, so this is the simpler version. So it calls itself with a simpler version of the problem. So the problem we have is 5. So we are reducing that problem, that 5. Okay, by 1. Okay, by 1. Okay, every time. So as you can see, so if we try to run our code, let us bring out the terminal, and we'll use GCC for compilation. Okay, so after there, we're going to run our programs. So here we're going to run /home. Okay, so if you are using Windows, you can just type PowerShell. Okay, just open PowerShell and use PowerShell. Okay, instead of CMD. Okay, because this one is not going to work. Okay, so open PowerShell and use PowerShell. Okay, so you can also just, if you are using CMD, you can just look here. I'm using PowerShell. Okay, for those who are using Windows. Okay, for those who are using Linux, the commands are going to be the same. Okay, don't worry. So for those who are using Windows, if here you are not seeing PS, just type PowerShell. Okay, and you will be taken in PowerShell terminal. Okay, so after doing that, let us now run our program. Let us run our program. It is dot slash home. Okay, like that. So if we do that, we get 0 output. Why are we getting 0 output? Have we forgot to save? Let us see. Let us save, and we see. Okay, let us compile again, and then we run. As you can see, we get from 5, 4 up to 1. Okay, so we have reduced 5 up to 1. Okay, up to 0. Okay, so and if we reduce it up to 0, we just return out. We just return out. We don't go into the next part of printing out that 0. Okay, so as you can see, so let us try to see if we don't include this one. Okay, if we don't include this base case, okay, which stops the recursion. Okay, so let us remove it, and we'll remove also this one. Okay, and also this one, even this one, like that, even this one. So in order to make our code our syntax very right. Okay, so if we compile and then we run, as you can see, we are generating a lot of like huge numbers. Okay, and this one is going to result into a stack overflows. Okay, as you can see. Okay, so let me remove, let me stop that, and then instead of providing reducing, let me provide 5 again. So if I do that, I'm going to come up with an infinity loop. Okay, so let me try it again. So we get an infinity loop when 5 is the only number printed out. Okay, so as you can see, so that's it about recursion. Okay, that is it about recursion. So here we had the function which is countdown, which called itself with the n minus 1, okay, until n becomes 0. Okay, so that one, recursion is used in multiple areas. Okay, it is used in multiple areas. Try to practice and learn it. Okay, so I think you have understood. Thank you.